Now starting. All attendees are in listen-only mode.
Welcome everyone to the second session of our new Mobile Mapping Essentials webinar series. Today we're joined by Ray, Pete and Christian from the TBC and Mobile Mapping team. So while Ray is presenting today's session, Pete and Christian are here to answer any question you might have. And since we are a little bit tight for time today and we'll have to end this after around 40 minutes, I'd encourage you to pop your questions into the question window here at any time, and the team is trying to answer as many questions as possible. So I'm handing over to Ray. Enjoy the webinar.
Thank you, Sophie. Hope everyone can hear us all right. Today we're going to show you something about what TBC can do for MX9, Trimble MX9 dataset. Unlike other webinars we usually do, I will jump into the resources section first to show you where you can find helpful information. And then we are going to show you a very quick overview of the MX9 TBC workflow and also show you the live demo in TBC, hopefully, on these functions: the data import, registration, point cloud classification, how to create a terrain surface or a corridor surface, and also how to extract other point features as well as line features. So I don't know where you are working from right now, but our teams are all sitting at home and working from there. If you have any trouble accessing your usual TBC network license or dongle that you left in your office space, please contact us directly if you are a Trimble mobile mapping user, and we will be able to give you a free timed license through June 30th, 2020, so that you can still access all the functionality as you need from the home office. Also, the demo data set today will be emailed along with the webinar recording in one day. So if you want to follow along the steps or try it out yourself, please download the data set and feel free to give it a try. For processing the MX9 dataset, you will need this TBC edition and module combination. First, you will need the TBC Survey Advanced Edition. Then on top of it, you will definitely need the mobile mapping module together with the MX9 MTA correction module. Also, in today's webinar, I'm going to show you some functions that are sitting in the scanning module. And if you are a GIS user, sometimes you may want to also get the GIS module to connect to a GIS data source. But today, this will not be included in the webinar. If you want to understand more about what TBC does and what MX9 is like, feel free to visit our product web pages. From there, you can download some useful utilities, find answers about licensing or installation, and also download some product bulletins and find some successful customer stories. For the past geospatial webinars, including a lot of mobile mapping ones and TBC ones, please go to our geospatial.trimble.com/webinars-home to find all the past recordings. All you need to do is to type in your name and email, then you can watch all the past recordings free of charge. Mobile mapping has our own video channel on YouTube. So if you want to watch these webinars and find some useful tips, feel free to subscribe to our YouTube channel, and you will find a lot of interesting videos over there. Similar thing for TBC, we also have a YouTube channel, and over there we constantly share new tips or workflows with our end users. If you want to download TBC for the first time and give mobile mapping a try, please do so. We currently have TBC 521 just released a few days ago, and you can download the latest version from the TBC webpage. And like I said, you can get a free TBC license from our Trimble representative until June 30th. Also, if you have other software or hardware related questions, our local Trimble partners are always your best friend. You can find them from this webpage. Besides this one mobile mapping essential webinar, we have other webinars going on to make sure everyone can still learn something new during this challenging time. You can find all the upcoming webinars from the same geospatial webinar webpage. The next mobile mapping essential one will be Introduction to Data Collection for Mapping and GIS Users. Peter will be your guest presenter, and the time for that one would be April 21st, 8 a.m. Mountain, Colorado time. Welcome to join us. All right, so let's jump into the workflow overview. Some of you may already listen to Peter last time in the Mobile Mapping Essential webinar and get a general idea how the MX9 data would flow. Here is just a quick revisit. After the trajectory is processed in POSPAC MMS, the data set will jump into TBC. And from here, we are going to compute scans and make further post-processing and extract some features or prepare some deliverables or intermediate products. And then also in TBC or Trimble MX, we will further extract features and manage the data and prepare the data for other third-party applications if necessary. We support some other common packages such as TopoDot or MicroStation or Mapillary. We will have these applications mentioned in the following Mobile Mapping Essentials webinars. Specifically in today's webinar, we're going to show you how TBC will work with MX9 dataset. Here we have some post-processing functions to help you create point cloud from the trajectory, register the scans to ground control points. We can help you to classify the point cloud and inspect the data set using different tools. We can design corridor surfaces, we can extract features, and also we can prepare the deliverables to prepare the drafting or extract features and export data into other third-party formats. Talking about deliverables, what things TBC can prepare. The first and also the most important thing is definitely the statistics. TBC is always good at maintaining the metadata. So every time when an MX9 data coming into TBC, we can generate some mobile mapping reports to give you a general idea how good the data set is. Here are also some snapshots of what TBC can do. We're going to go through each of them. All right, so I'm going to jump into the presentation and live demo. The first section I want to definitely cover is about how the MX9 data can enter TBC and how we are going to register these scans if necessary. From the left side, you can see a typical MX9 data folder structure. We have all the raw data sitting in this folder. And like we said before, the first thing we want to do is to bring the real-time POS information and probably your own reference station information into POSPAC. In there, we are going to generate a file called sbat.out. This will be your processed trajectory. Looks like a line that represents your driving trajectory. Once we get that trajectory, we can bring that into TBC by drag and drop your MXDB and your ground control points into TBC. Then TBC will do a series of registration and make sure a new registered trajectory will be created. From that correct trajectory, you can continue your other point cloud processing steps. How does it work? Let's jump into TBC and take a look. Here, as you can see, I already have a TBC project created. The first thing I want to show you is about the coordinate system. If you are not that familiar with TBC, we always want you to set up the correct coordinate system before you drag and drop in the MXDB from MX9. For example, here, this data set is from Colorado Central Zone in the United States state zone. So I chose this coordinate system. And then I brought in my mobile mapping mission, which is called Silos. And inside of this mission, I have 2 runs. But if I toggle the correct trajectory on, you can actually see these 2 trajectories are connected to each other. So the first thing I did in this data set was to split run. I can quickly right-click on a run and choose to split it. Right now, this icon is grayed out because I already generated some point clouds on top of these trajectories. What does the trajectory, the point cloud looks like? If you want to generate them afterwards, you can click Generate Scans from the context menu. But here, I'm just going to show you the results quickly. Here is the point cloud we generated by generating scans. What it does is when we go to the mobile mapping tab and click Generate Scans, we will ask you which run you want to process and also ask you if you want to use the default filter or use some advanced settings for the filter. And then we'll also ask you if you want to colorize the point cloud. And then once you hit the process, we enter the point cloud generating mode and send you the point cloud. Here I'm going to show you the true color and maybe rotate a little bit so you can see some surrounding information about this data set. This is going to be the data set we work with today. Once we have the point cloud generated, I also want to compare the point cloud to some existing ground control points so I know how accurate my data set is. That's also why we have these ground control points or targets marked on the ground. How do I register my point cloud to these ground control points? If I want to start with my first run, eastbound run, I can right-click and choose Register a Run. So here I can give this registration a name, choose the registration type, and if I already know which point is my ground control point, I can choose it from either the Project Explorer or directly from my view and add the selection to control. And to pick the target, I'm going to highlight this point and the smart picking tool will pop up asking me how I want to pick that point. Since I already have a lot of data sitting in here, it's not showing me the correct one. Okay, so now I'm ready to hit somewhere near my center of the target. And this validation window pops up. I can now manually move the crosshair to the exact corner where I want to click and hit validate. Now I can continue the same routine for point 3, point 4, point 5, and then compute a new trajectory and apply the new trajectory to my run. But here I'm not going to finish the whole process because it's a little bit time consuming. Instead, I'm just going to show you what the new point cloud will look like. Okay, where did the point cloud go? Huh? Okay, sorry. I see. Probably need to turn back on everything. Okay, there we go. So this is the new point cloud we're looking at. And I already updated the eastbound. So now it's the time to update the westbound of the street as well. Because as you can see, we drive on the same road for twice and we have a lot of overlapping. So for the westbound road, I don't have to also register it to the same ground control points. Instead, we can now go register run to run so that I can register my westbound to my eastbound. And after this is done, I can also update the scan and open the cutting plane view to see how well these runs are matching with each other. So here, let's give it a try. I'm going to open the cutting plane view. And mobile mapping will already create a cutting plane view definition for me. So here you can see the cross section of our point cloud. I'm going to change the thickness to maybe 0.2 meters. And as you can see, all the point clouds are merging with each other. Remember that they are actually from two different runs. Before the registration, if we turn everything back to the original one, you can see an offset sitting in between the runs, right? Now we have all the both runs registered. We can enter the next step called classification. But before that, we may still want to look at the statistics because that can be part of your delivery. So if we go to mobile mapping tab and jump into mobile mapping report, here you can see all the information about your runs in your mission, including how the sensors are calibrated, and also for each of this trajectory, if I click the link, it will jump into that trajectory and show me the residuals. Okay, just to summarize the steps in the registration section, I have these bullet points put here, but we're not going to read it again. Instead, I'm going to jump into point cloud classification and clean up. So if you're already familiar with TBC scanning module, we always classify the point cloud automatically and give you 5 different regions to work with. They are buildings, ground, high vegetation, poles and signs, and power lines. Of course, the algorithm cannot always give you 100% accurate results. So some human interference afterwards or cleanup is still necessary. In TBC, you can always add the misclassified point cloud to the correct region, or you can create any region you want and add those add point clouds to those new regions. Some handy tools I want to mention are the rectangle select or polygon select tool and the keep in, keep out tool. Again, let's jump into TBC and show you the result. Here, I already classified my point cloud, so I'm just going to show you all the point clouds in the region color. As you can see, from the point clouds tab, if you click classify regions, you can then determine which region you want to extract from this point cloud. That's exactly what I did. And now to look at the result, all the buildings are in blue color, ground is in this brown color, power lines are in red, yellow color, poles and signs in red, and trees in green. And this cyan color is representing all the unclassified point clouds. If I realize something are misclassified from this result, I can jump into those area and manually clean it up a little bit. So to give you just a quick example, if I turn off all other regions and just leave the unclassified area on, maybe I can see there is a power line still sitting here, but it's not classified correctly. I can click Add to Region to open the command. And use the polygon select tool from the bottom of TBC and start draw a polygon around this power line. I'm not going to go very precise. Once an area is selected, it will be highlighted in this orange color, and then I can choose to add it to the power line region. All right, now it's disappeared, and if I turn back on the power line section, I should see it showing up there. Or if you want to always create another region to represent, say, all the cars, you can do that very easily. For all these cars, you can select them. And since it's not an existing region yet, I'm going to create a new region and give this new region a name. Maybe I'll call it vehicles. Now, as you can see, this car is assigned with the new color. And if I turn off the vehicle region, it would also disappear. That's everything I'm going to cover in the classification and cleanup section because it's quite straightforward and easy. Next, I'm going to show you some functions in TBC to create terrain surfaces as well as the corridor surfaces. Now we have the point cloud classified. I want to create a terrain surface to represent the existing road condition. As you can see, I already separated this road point cloud from the original ground point cloud, so I can work with it directly. To select the whole region, I don't have to Control A. Instead, I can just click anywhere in the point cloud to select it. Then I'm going to the Surfaces tab and say Create a Surface. In this region, we have over 1 million points sitting there, but I don't necessarily want to include all the points to create a dense enough, super dense surface. So I already changed the setting in my options to ask TBC only use 20K points to my surface creation. You can always change the setting anytime you need. I'm going to call this new terrain surface existing terrain. And that's everything I need to change. Click OK. There we go. A surface has been created along this road. If we want to take a closer look, I'm going to turn off my point cloud regions and check this surface. As you can see, we don't have that many vertices sitting there because we are only using 20,000 points from the original point cloud. Also, I can change the display of this surface so we can quickly detect some elevation change. There we go. Now we have an existing terrain for this road. As an end user, I may also want to redesign this road so I can probably widen the road or add another ramp to the existing road or something like that. To do that, I'm going to create a corridor in TBC. How do I do that? Usually before you start your corridor design, you should already have an alignment created and also some a corridor template pre-designed by your engineers. So here I already have an alignment pre-created along this road. I'm going to now create a corridor on top of it. I have already started half of the corridor, but in this case, since we now have a terrain model to work with, I'm going to add my terrain model as a reference. Apply. And also, when I start to edit the corridors template, you can already see a right lane and a right shoulder pre-created for my road. To finish this road design, I will be mirroring the current instructions to my left side, so I don't have to start everything from scratch. Now you can see the left bound also created very quickly. And the red and the blue colors showing here are the cut and fill from the existing terrain model we just created. If I want to see if everything will be all right along this whole road, I can use the slide bar to check the information. Seems all right. Our design is not too off from the existing terrain. I'll be happy. Now the corridor is created, we can close the editing mode. The next, and also probably the most commonly used function we want to cover is feature extraction and CAD. I'm going to cover how TBC can help you to extract the point features as well as create necessary line work. And also, if you want to, label these features. Coming back to TBC, I'm going to jump into the feature extraction mode. You can already see some of the points and some of the polygons or lines pre-extracted by me. But here I'm going to show you how they were done. So let's start with point extraction. Before I jump into there, I want to import a feature code library. How do we usually do it? You can always use the same drag and drop method, but here, since we have two files we need to pre-import, I'm going to use the project settings method, go to the feature code processing window, and bring in a global feature FXL that always ship with TBC, as well as the feature extraction attribute map.exl. I'll explain how they work afterwards. And the next thing I want to do is to make sure I have some point cloud regions on. In this specific case, due to the time limit, I'm not going to process the whole point cloud. Instead, I'm going to select a small area, maybe here. And I'm going to only keep in a necessary area for me. Now I have some ground and trees on. I can enter the extract point feature mode. Here for the extraction type, we now have three different options: tree, pole, and sign. For the tree, we have manual mode as well as the automatic mode. Since this is the most exciting one, I'm going to demonstrate that one first. I will click Extract Tree Attributes. Notice that this is just a one-button click, but then TBC will go through a series of calculations not only returning all the trees positions at the bottom of the trunk, but at the same time, it will try to return some necessary attributes about that tree. For example, what's the trunk diameter, what's the spread, and what's the height of that tree. And all of these are done automatically by the engine. So as a user, I don't have to go through too many interference steps. As you can see here, we have these trees extracted. We have the spread, the trunk, the position, as well as the height. I'm not going to do further editing, so I'm just going to give the starting point an ID. I'll call it maybe 50, starting with 50 tree. And for the feature code, this is an important step to tell TBC, is this a broadleaf tree? Is it, I don't know, a palm tree or something like that? So I will just call it in general, broadleaf tree. Once I put in the feature code, this attribute area will be enabled. And as you can see here, it will try to return all the tree spread values to this attribute field called spread, trunk diameters to the trunk field, height to the height field. Of course, there will be some unmapped attributes. For example, the type of the tree, we're not going to worry about that yet. By clicking the add, all these trees will be added to our project. Yes, I want to create all of them. Now, if I turn off the high vegetation region, you can see all the trees popping up. And if I also highlight one of the points and check its properties, you can tell the height, trunk, and the spread information of this tree. Maybe for the type, I'm also going to say this is an oak tree. There we go. We have 9 trees created automatically. What happens to the pose and signs? We can also give it a try. I'm going to turn on the pose and signs region. For example, for this one, this is a power pole, sorry. And if I want to extract it, I'm going to first change the extraction type to pole. Notice that for pose and signs, we only have the manual mode available today, but we will keep working on adding more automatic modes to more extraction types. So here it will ask me to pick a point on the pole, anywhere on this pole. So I can just do a quick click and then either use Enter key or this Extract Pole Attributes button to extract this pole. As you can see, the position of this pole has been returned, and TBC detects the trunk or the diameter of this pole, as well as the height of this pole. So no further editing needed. I'm going to change this point to 59-pole. And for the feature code, since this is a power pole, I'm going to use an existing feature code power pole. If it's a light pole, I'm going to use LP to represent it. This pole diameter and height will enter the correct attribute fields. For the signs, we follow the exact same step, but the difference is I'm going to use the extraction type sign. Pick a point from the trunk and hit enter.
Great, just a little reminder, unfortunately, you will have to end this webinar in a few minutes.
Okay.
So if anyone has a question, just pop them into our question window now. And Ray, maybe if we can finish up in only a few minutes, that would be great. Thank you, everyone.
Okay. So here we have a sign extracted. I will change the ID to reflect that. And for the feature code, I'm going to put in signpost. And this one is a stop sign. So I'm going to choose that from the drop-down menu and add. It's not added, but well, since we're running out of time, I'm just going to show you some existing signs I have extracted. Maybe, where are all my signs extracted? I don't see them. Oh, well, you get the idea of how you can extract these signs. Now back to the plan view. Another thing I want to mention is how we can extract these line works. So if you're more familiar with the GIS workflow, you may think maybe I want to just start a line and then worry about the attributes. Also in the surveying or engineering world, the feature coding is another popular way to generate these lines. So here I'm just going to quickly show you a way to extract a line using the GIS way. Go to the CAD tab and say create a line string. I'm not going to worry about the name and anything. Enter the editing mode. I'm going to follow the current road. Maybe I will change the color a little bit to show the road. I'm going to start somewhere here, and I can say I want to actually get a smooth curve instead of straight line. This is how quickly you can create a line string in TBC. And now if you want to further edit the feature, go to the properties, and you can assign this feature to different feature class or feature codes. In this case, it's edge of pavement. So I'm going to enter that and then change the surface type. Or in this case, if you want to also extract these stop stripes, here is what we can do. I can start creating points. I'm going to call them marks. For the feature code, I'm going to call them pavement mark. And since this is a square, I'm going to use a control code called start rectangle. Now it will be easier because I can just go click on the point, enter for the next point, continue using the same feature code, but remove the line control code. And also I will need the third point to determine the width of this rectangle, and then hit enter to calculate the feature code. Now we get a square auto-generated for this stop stripe. Also in TBC, sometimes you may want to extract a curve to represent the power line. If we do that, cutting plane view is your best friend because you can always create proper profile view to show all the power poles or power lines. As you can see here, I already have a plane predefined. I'm going to change the thickness so you can really see all the lines. This time I'm going to, oh, not this region, turn back on the power line region. And let's say I want to extract this line showing up here. I may go to the CAD tool again and choose best fit line. To select this power line, I'm going to use the same polygon select tool. Circle the area I need. And then choose what kind of line I want to extract. In this case, I want to generate the polynomial curve in 3D. And then hit apply. There we go. This line has been automatically calculated. And in the plan view, we should see this line also showing up from here. So, okay, to close the view. And here in the 3D view, if we look at these power lines, you're going to see all these lines showing up. Same thing here. After I created this line, I can now change the feature to power line. And if I have other attributes I need to fill in, you can now come here and measure this line's lowest point to the ground and get the clearance. Seems like we're running out of time, but the basic idea is inside of TBC, you can post-process the trajectory, generate the point cloud, register the scans to ground control points to guarantee the best precision from the point cloud. And then from the point cloud, you can create a lot of features. You can extract a line work like I did here. You can label these features and also in the end, draft everything into nice drawings and also deliver the result to third party. If you want to export your data to third-party packages, always go to the Export tab and go to Mobile Mapping. Choose these existing MX9 exporters to export the point cloud as well as images into Soft 3D, TMX, or Topo.dot format. That's about it. Any questions? Sophie, do you want to wrap it up?
Yeah, I think that would be good. I think we had definitely a few interesting questions and pretty much all of them were answered. So thank you, Ray. That was super interesting.
Okay. Well, thank you, everyone. Thank you, Peter and Christian, to help answer all the questions. If we couldn't answer it right away, we will follow up with you after the session, and you will get the satisfying answer from us.
Thank you, and don't forget to join our next session on the 21st of April. We'll be publishing all the upcoming sessions on our webinars page. So have a nice day. Thank you all.